Hello, good evening and welcome to this evening's webinar entitled IB with TI-Nspire Exam Readiness. My name is Brian Lannon. I will be your host for this evening's webinar, and I won't read that blurb to you, but it basically says that I've been teaching for a long time in a range of different places and a range of subjects. Now, the two presenters this evening, Bojina Graham from Wesley College, and I'm sure you can read, but I will read it to you anyway in case you're getting your cup of coffee at the moment. Bojina is an experienced VCE specialist in mathematics, MM Mathematics CAS and International Baccalaureate high-level mathematics teacher. She's also held roles such as the VCAA Assessor for Specialist Maths, an International Baccalaureate Examiner, and Deputy Chief Examiner for the International Baccalaureate High-Level Mathematics. So she's a pretty handy person to be listening to just as you head towards your exams. The other presenter this evening, who also from Wesley College, Pam Durant, and she's been teaching in the IB-DP program since 2006, also a senior examiner for the high-level paper 2, and has taught right across the senior curriculum.
Thank you. Okay, so, well, I thought I'd get us started with just a quick talk about the press-to-test mode, which all the calculators need to be set in for examinations. So when the calculators are set into press-to-test, there are a few things that are no longer available, and also there are a few changes that the student should make fairly quickly into the exam time. So first of all, the key thing for the paper 2s, for standard level and high level, and for both papers in studies, is this idea of 3 significant figures. So if we just have a look at the home screen, if you go to the settings and then go to your document settings, the standard setup after it's been put into press-to-test is that the calculate screens will be in float 6. I highly recommend that you immediately change that to float and make that your default. For studies, they may also have to change this to degrees, would be an ideal thing, but I'm going to be looking at some standard level questions, so I'm going to leave that in radian. And if they make that default, then they're all set to go. And if I go back now, I also need to change the settings within the graphing screen. So I've opened up a graph screen here. The settings are within the menu for graphing, and once again I recommend that they go to float as opposed to float 3. The graphing angle for standard level and high level should be kept at radians. So once you're all set to go, then we're ready to start doing some other things that are particularly good with setting up our calculator. So for circular functions graphs, and this is particularly in operating system 4.2, or some might have already gone on to 4.3, one of the window zoom features is that you can actually change the scale into amounts of pi, which is quite handy. So here I've got a function that you might like to enter, 2 sine 3x, and the first thing I'm going to do is get it ready to answer the question that might have come up. So what I'm going to do is get the entry line there, go back to this one, and I'm going to put in a domain. So quite often the standard level and high level questions, when they've got a circular functions question, they need to actually enter a domain. So we can do that through the control equals menu and the given, and I'm going to put in negative pi on 2, and to make life a little easier, which can be for the kids, rather than going to the pi menu, I'm actually just going to type pi and divide by 2, then back here, and I can put in some less than or equal to x, and once again less than or equal to, and we might go to 2 pi. Once again, I can just type the letters pi, and it recognises that that's the graph I want to see. But at the moment, I've got this scale here, which is the standard graphing scale, but it's not necessarily the best one for trigonometry graphs. So I'm going to go to the window zoom. Oh, got out of there too quickly, sorry. Let me try that again. The window zoom, and the zoom trig fits it into a scale from negative 2 pi to 2 pi, and this negative 4.19 to 4.19. So it's a better fit for the graph, but still, once again, the scale is in this 0.5 of a radian. Not all that useful for finding features of the graph. So what we can do is we can change that in window settings, and it's at this X scale. We can actually change and put something else in. So I'm going to put in pi on 6. I'll actually use the pi button this time. Pi divided by 6, just to have a look at that. And if I enter that, you can see that now my graph is actually intersecting on those markers, which pi on 6, the decimal equivalent is 0.523599, obviously. So we can actually count off those x-intercepts as we go. Now I chose pi on 6 because I recognised that my function had that coefficient there of a 3, so I chose something that had a common factor with that. But that's a nice way that students can actually count off their x-intercepts in that way. Right, so in press to test, the GDC defaults to radian setting and float 3, so changing those will make a difference to actually having that ready to go. And of course, for standard level and high level, they do need to be in radian mode, but there is always a question in standard level, which is an applications of trigonometry. So we're in radian mode, and in 4.2 and 4.3 you'll see that listed up in the top right-hand corner there. But what we can do is still do calculations in degrees while we're in radian mode. So if I go to the trig menu, go to sine, and I want to do sine of 37 degrees, rather than doing a conversion of 37 degrees, what I can do is actually use the degree button. Now the degree button is in a few places. So there's one here, right there, that we can use, but that's not the only place it is. It's also in the pi menu there, and I'll escape out of that. And it's also in what I like to call my favourite things menu, which is the control catalogue, and you can see it up there. So those are 3 quick ways to find the degrees, and of course you can find it within the catalogue. But the beautiful thing is, it's now going to say, oh, you're in radian mode, but I see you want to work in degrees. Well, I'll help you out and do that for you. So it can do the calculations if we tell it that we need to use the degree mode. So that's a really handy thing rather than having to change the angle setting every time the students are doing questions. Likewise, if they happen to do the inverse sine function, and let's just put in a particular value, let's say 0.86, what I get at is, of course, an angle in radian mode. But if I've got my question and it says to the nearest degree, then I'd really like to change that to degrees. I don't have to remember the conversion factor because the calculator can do that for me. So once again, going back to my favourite things, which has got the symbols above the catalogue there, there's this really useful arrow. And because I've just immediately gone to press that, it said, oh, you obviously want to use the answer you had. So I'm going to do that, and I'm going to type in DD. That stands for decimal degrees. And if I press enter, it tells me that 1.035 radians is 59.317 degrees. So to the nearest degree, we would say 59. If it said to the nearest tenth of a degree, then we could go 59.3. With our 3 significant figures, we would say 59.3. But I could also go up and grab that previous answer, and I can convert that, so using that same conversion arrow, to DMS. And that, of course, stands for degrees, minutes and seconds. And so now I can see that it's 59 degrees and 18 minutes and 59.69 seconds there. So if it was to the nearest minute, then we could say 59 degrees and 19 minutes. Very few questions now within the IB actually go to minutes. It is more the decimal degrees. Okay. So another thing that the calculator can be used for, and this is quite good within standard level in particular, but sometimes in higher level as well, is to find the equation of a tangent. So our calculator can do this within the Analyze Graph and Geometry menus. Now, some of the geometry features are switched off within Press to Test, but we are still able to find the equation of the tangent. So it says that it limits some of the features, but it doesn't switch them all off completely. So I've got a function here, y equals x plus 1x minus 2, and I'd like to find the equation of the tangent at x equals 2. I've just chosen a cubic, but it could be any function. So I've saved a little bit of time here and graphed that already. So what I'm going to do is get a few things that would be useful to show for my exam writing down an answer so that I can get all the method marks. So one of the things that would obviously be good if I wanted that equation of the tangent at x equals 2 would be to find the y coordinate. So I can do that with the trace menu and the graph trace. The graph trace menu, as I've said in previous webinars, is fantastic. It's very underutilised, but the immediate thing it tries to do is always find a y-intercept, which it has in this case. And I can point to points on the line and it will tell me the x and y values. But better than that, I can just type in the value where I want. So if I just press the number 2, it immediately pops up with the box x equals 2. And so I press enter, and it tells me the coordinates are 2, 6. Now the downside of graph trace is as soon as I go to do anything else, this will disappear off the screen. So I won't have that coordinate point. So in an examination, I should make a note of that the point is 2, 6. So the next thing I'm going to do is analyse the graph, and I'm going to find the gradient at x equals 2. So here it is, I'm in the gradient function, and I could just land on a point, but I specifically wanted it x equals 2, so I'm going to once again just type the number 2, and it immediately says, oh, so you'd like the gradient here? Well, that gradient is 11. So now I know two things about the function. The coordinates of the point, 2, 6, and I know the gradient when x equals 2 is 11. So my next thing is to find that equation. And the reason why I find the gradient first is because it marks a point, and that's pretty handy when we go to the geometry menu. So here I am going to the geometry menu now, and in Press to Test, 3, 4, 5 will be greyed out. I can't put the software in Press to Test mode, but they will be greyed out. But 1 and 2 will still be available. And in number 1, points and lines, I can go down to tangent. All of these things are available within Press to Test menu. And so I can then just go to my point that I've already marked, and you can see that already, before I even press anything, it's telling me what that tangent line is. And there I have it at y equals 11x minus 6. So I found the equation of the tangent fairly quickly. So the wording that I would expect to see students show on the exam paper would be the location of that coordinate point. So at this point we would put in that that was the point 2, 6. We would want to find the gradient, and so we could call it m for gradient is 11, and then we can use that geometry points and lines, and get the equation of the tangent, so y equals 11x minus 16. And there we have the information that would certainly score all of the marks for that particular exam question. Okay, so another feature that perhaps is underutilised is for probability and probability distributions. So these come up in both the standard level and high level courses, and one of the things that I like to show the students is that you can actually use the spreadsheet application to do your expected value and variance for a probability distribution, a discrete distribution. So here I've got a spreadsheet and I've listed in X value and probability. It is good to call your list a particular name. Doesn't need to be too long. I've gone into X value to show you what I'm doing, but for in the exam, the students might like to just call that number or something, NUM, even N. Try and get them to avoid using X or Y as their variable list because they're already used in their functions. So, calling it something else is quite useful. So I've got a fairly simple distribution here, which is typical of standard level. The higher levels could be a little bit more complex than this, but I've just got the X values being 0 to 4, and then the probabilities which add up to 1. So what I'm going to do is I'm going to do the stat calculations, the one variable statistics. I can do it within the spreadsheet page, but I actually like to do it on a calculate page, and this just shows the connectivity of all of the pages that we have. So if we go to menu, statistics, stat calculations, and the one variable statistics, now I know my lists look like they're in two lists, but it's actually one list of the variable, and that was the X values. So I then pop the X value into X list, and if you go to the arrow here, I can put the probability in as the frequency, and I press OK. Up comes the list of values, and the most important thing is this X bar. That's our expected value. So we've got our mean there. For those of you doing the high level option, there are lots more interesting things here with the sum of X squared, etc. But the other one is the SSX, which is the variance of X. So that's also there at 1.86. And you can see sigma X, the standard deviation, which of course is the square root of the variance, is also listed there. So I've written those out so that they're easily found for you. Okay, so more features of the Nspire in the algebra and functions are all of the solving approaches. So we've got msolve, limsolve, polyroots. We can use regression, and we can use the graphical approach. So I thought I would just show a couple of these. So in msolve, one of the things that it can do is actually obviously find a solution. The limitation of msolve is it will only ever find one solution at a time. So if we want a specific answer, then sometimes we need to add in a domain. So I'm just going to copy this, ready to go on to the next page. So menu, algebra, msolve, and I'm just going to copy that in, comma x. So I'm solving sine of e to the x equals 3 minus x squared, and I get an answer of negative 1.677, etc. But specifically the exam question might have had a domain where that wasn't an appropriate answer. So what I've said here is I actually want a solution that's greater than 1. So what I can do is go up and grab that previous calculation, and once again add in through the control equals menu the given symbol, and I can tell it, okay, well I want to use x greater than 1, and it tells me, well, this is the answer here. Now, there may in fact be more than one solution greater than 1. So what I might do is just see if there are perhaps any more. So I might just try in 1.8 because it's hardly likely that there would be another solution between 1.79909 and 1.8. So I'll see if there are any more. And it says, no, there are no solutions to be found. So there is only the one solution when x is greater than 1. Okay. And one of the other solving menus is the LinSolve, and this is particularly good for systems of linear equations. And one of the places that this comes up is for a normal distribution type exam question where you have to find the mean and the standard deviation. So if I just get the LinSolve menu up here, oops, wrong one, sorry. Let me go back. Clicking too quickly. So solve system of linear equations. I've got two equations. I'll call them x and y, that's fine. And I'm just going to go back and get this one and paste it in. I'll come back and change those to x and y in just a moment and paste that in.
That's great. The cut and paste is terrific, isn't it?
It is. Yes, yeah. I do enjoy the cut and paste.
Yeah. And then of course we just change the variable names, x and y.
That's it.
Yeah.
Yeah. So I've just changed those there so that it all matches up. And now what happens is it goes, okay, there's an argument error. And the reason why is if we go back to it, it doesn't like having the divide by y in both cases. So LinSolve is not going to work if it doesn't look like a regular linear equation. It's an easy fix. It's a matter of getting your students to actually understand that they need to multiply through by that y. So rather than having it in this form, they would have 1.036 y equals 90 minus x. And if they do that to both equations, it works brilliantly. But that's a problem in that it's saying it's not actually linear in this form. So we need to make it look like a system of linear equations. So that's just one of the pitfalls that sometimes students come across and they can panic about.
The solved system of equations would work?
So that's not part of the possibility. We've only got systems of linear equations.
Okay, yep.
In IB.
Yep.
Okay.
So even though it's linear, we multiply by y and it will work.
That's it. So that just makes it all work very nicely. But yes, it's just something to keep in mind for those particular equations. So one of the things that does come up in paper 2, whether it's standard level or high level, is that they try and bring in this idea of unfamiliar functions and getting students to analyse what happens with an unfamiliar function, just like they would for all of the standard ones, our gallery of graphs, if you like. So the unfamiliar functions quite often come up as an application style question, and quite frequently they can be kinematics. So this is similar to an exam question a couple of years ago in standard level, that we were given a velocity and we're given a specific domain, and the velocity function we can see is a linear function there but raised to the power of t, so something not quite familiar. And they needed to find the value of t when the particle is at rest, and then find the value of t when the acceleration of the particle is 0. So what we can do is draw a graph, because that's the most powerful thing that the calculator can do. And of course, when we put it in, 0.4, we need to make sure that we put it in for x and not t, because our function is for x. And then to the power of x, and then make sure you get out of that power, a minus 3. And so we get this really crazy looking graph, but if we go back and have a look, we're told only between 0 and 5, so we're actually only interested in this. So once again, we could put that domain restriction because it is really important that the kids actually put in their restrictions. I quite like to put all the bits in and then just fill it in with the less thans in the right spots, but that's up to the students. So we have that there, and the question was when the particle is at rest, so we want velocity equal to 0, so we want that x-intercept, so we can go to Analyze Graph and go to 0, our left and right, as the students would hopefully see. Now in the exam, what we examiners want to see is this graph drawn, and we want to see that 0 marked in. And then we're happy to give full marks, but we would like to see the graph because it's usually 2 or 3 marks, and with just the answer, they will quite often only get just the answer mark. So we need to see that graph. The other part of the question was to find when the acceleration of the particle is 0. So one of the neat things that all the Nspires do is that they're able to graph derivative functions for us, even if we don't know what that derivative is. So we can enter using what I like to call my favourite things menu, the derivative function for x, and just keeping a note of what the previous function was. For me it was f3 of x, and we can graph that there. Now something to keep in mind, if I started with a position function and then graphed velocity and then wanted to graph acceleration, it's actually best to only do the single derivative each time. So graph position and graph its derivative, but then graph the derivative of that previous graph, not to do the second derivative because it tends to whir through a lot of time. Anyway, getting back to this question, when the acceleration of the particle is 0, so once again that's an x-intercept. So I can analyse the graph and the 0, and this time because I've got 2 graphs here, it's saying, hang on, which graph do you want to use? So I need to click on that first, and then I can get that acceleration being 0. That's one of the last things that I wanted to go through was the fact that when you're doing the extended response questions, in particular in the exams, it's a really neat idea to actually go to your document and insert and problem. And then, so what happens now, you can see that I actually had 21 pages in that first problem, but now I'm up to problem number 2. If I type in f1 of x, which was previously defined, nothing is going to, if I type in f1 of 3, nothing is going to happen because it's saying there's no function defined in this one. Whereas if I'd gone back over to one of these, I could have, if I'd inserted a new page within this problem and do f1 of 3, I'm going to get a value because that function is defined within problem 1, but within problem 2, I've now got a fresh start. So this is quite good for students who are going to then perhaps do a graph within here. So I can now open up a graph screen, and so I'm ready to start a new series of things to do, but they're all connected within problem 2. So it's a really good idea for those extended questions that the students do them within different problems, because if they suddenly come up with an idea later on, they can quickly switch back and continue working on that one without having to redefine anything. Finally, the last thing I want to do, and I don't want to take up too much of Bojana's time, I've got a little Word document here that you can flick through. There's some bits about how to maximise your mark, things that are within paper 2 and paper 1, some common notation errors that we do expect the correct notation. So for a vector, we expect that the equation of line to be called R, inverse function notation, and integral should have the dx, etc. Some little things there about examiner markings, but I did want to just highlight a significant figures problem. This was from a standard level paper a couple of years ago, and it's a standard level question in that it's all about the application of trigonometry. But if you go through the mark scheme associated with it, the first part you get an answer of 10.5 to 3 significant figures. And in part B, if you use the original value or the 10.5, you get the same answer. But in part C and D, if you did not use the fuller answer, 10.4981, you actually do not get the same answers to 3 significant figures, and so those questions were marked incorrect. So the students received very few marks for part C and part D if they happened to use 10.5 rather than 10.4981. So it is important that the students go back and use their original answers. And lastly, when they're talking about the n values that you get in sequences and series, binomial distribution, binomial expansion, they must be integer answers, so they do need to make sure that they round to the appropriate integer. Okay then, I am going to stop sharing now and pass over to Virginia.
Good evening, everyone. So in my part, I will actually look at 3 different set of questions. The first one will be looking at high-level maths and continuous random variables, and one with the absolute value, and really the importance of defining especially the piecewise functions. And we still find that the students are not using the calculator very efficiently in those questions. Then I will work through some studies questions, so again on familiar functions, the chi-squared and basic statistics, because that comes on the exam all the time, and some calculus questions. And lastly, I will look at normal distribution, as this is covered in each of the studies. So starting with some easy basic questions for studies, then looking at standard level and high level questions. So that's what I'm planning to do. So the first question we'll look at is high level continuous random variables question, when the PDF is defined here for x values 1 to 3. A is a constant, so the question says find the value of A correct to 5 decimal places, then calculate the mean, variance, and find probability x is less equal to 2. That's a bit of a hint to see that the function is symmetrical, and then find the interquartile range. So if we think about that, that's our function. We know that the area needs between 1 and 3 of that needs to be equal to 1. So what we can do, we can just find the area between 1 and 3 first, and then find 1 over and store this value. So I illustrate like again how we would do that. So of course we need to get the definite integral, and we put the limits 1 to 3. Then we use the fraction, tab, fraction symbol, and enter our function without the constant at this stage, because we don't know what it is, 4x minus x squared, and tab to get the x, so enter. And we know that we had this a here, so we need to go now 1 divided by, and we grab this, and we get the answer, and now we can store that as the value of a. So, because I already have done that, so it comes bold, but that's the value of a stored. So now when this value of a is stored, we can define our function, and that's a big advantage defining it again. So because, as I said, I have already done that, but if I define the function, then I can use this function later. and I would put my value a here, which comes bold because I already stored this value, and I say x squared here. So it's done. So the big advantage of this is that now the question was asking for the mean. So of course, if I go 1, 2, 3, and I put my function, but for the means I put x times, we need to use this times there, times f in x, hard with one hand a bit, dx, and enter, so I get the mean value 2. Now if we want to find the variance, so we might save a bit of time, so I can grab this thing here and just do the square there, and now I can go minus, and value mean here is easy, but it's not always that easy, so I can just go minus that squared, and I get the variance. So that is the advantage of defining the function and using it later for mean and variance. We're getting lots of wrong answers when marking the exams because the students don't use the calculator very efficiently, but that would help them with questions of this type. So the other part of the question was asking again to find the probability that x is less than 2, which is 0.5, so we can see this symmetry, and also we can graph it by restricting the domain as Pam already shown, so it is showing us this bit, and the function, the distribution is here, the PDF is symmetrical. So the other question was asking for the interquartile range. This, of course, is a bit tricky. Doing trial and error will not get us very far. Yeah, we're getting close to 0.5. We could do the table, but again, it is not working particularly well. So what we can do, we can actually enter as another function integral. We know it has to go from 1 to a particular value f in x dx, and we have to actually intersect 0.25. Now, I did it in press to test on a handheld. On the computer, it's like that immediately. It is rather slow, very slow on the handheld, probably 2-3 minutes. The little circle going round and round and round, but it does work, okay? So it is something which, of course, helps a lot with finding Q1 and Q3, because otherwise, with some functions in IB, even high level, we don't do partial fractions, so they wouldn't be able to actually do it by hand. Once I get the point of intersection, I actually click on that and I use control variable to store it, and I called it Q1. So now the calculator remembers that it is Q1. So what I can do now, I can recall this Q1 and I can check, okay, did I get the right value? 1 to Q1 is 0.25. Yep, that's good. So then I find this little difference on our graph. If we have from here to here and 3, so to find Q3 or otherwise, so that gives me the value, and I double that, which gives me the interquartile range. I could, of course, also find Q3 with some little manipulation and then find out that Q1 to Q3 is 0.5, depending what the question is asking for. So that is extremely handy using this graph, even though it is slow, but that would be much faster than trying to do it by hand. And as you can see, I again used what Pam was saying, that we are having, for each question I have a different problem, and I actually suggested that to my high levels, and they said they used it in trial exam, and that was very handy because they might come back to the question, and if that's all one problem, they have like 50 pages, and it's very hard to find where they are. The other function I look at is, again, continuous random variable defined as a piecewise function with absolute value, so it does look complicated. So we want to sketch the graph, and yeah, those questions do occur on the exam very often. Again, we want to find the value of k, state the median and mode, and then do a bit of a conditional probability. So I'm doing a similar things as we did before. I need to define this function, but it's very important that we actually use the correct template. So use the piecewise template, and once the function is defined, you can do all the calculations, and it will be using this piecewise function. So that's what we need to do. However, firstly, we need to do some checks. So I'm looking from -1 to 1, which is the first part of the function gives me the area under the graph 0.5. So then if I find the second half without my constant k, I get 4. So of course I have to divide 4 by 0.5 to get me the value of k. And as you can see, I again stored this value. So the calculator now remembers what this value is. Here we have the whole numbers, but that's not always the case, and as Pam indicated, the accuracy is important, so we don't want to use 3 significant figures for further calculations. Now, since I have this function defined and the calculator knows what f in x is, yeah, I did some coloring here, but it will draw it over the particular domain. Having this picture is very easy to determine the mode. It is 0 because we get the peak here, the highest value, and the median is also easy because 0.5 and 0.5 are the areas. So these are the advantages, again, by using our f in x predefined, and then we could find any probabilities. The last question was about the conditional probability. So here I need to find 1 to 5, and I used so that gives me the probability again, which we sort of know, and then this probability, and I divide one by the other to get the conditional. The last question for high level I have here, and again a typical question on the exam, we want to find the area enclosed, and here we have the graph of arc 10 2x plus pi on 3, the y-axis, and the line y equals 5 pi on 8. I chose those values on purpose because there's no way you can do it algebraically. And funny enough, some students do attempt that, and we see a lot of integration by parts and other funny things they're doing on the calculator paper. So it's really important to know, nope, that's a calculator paper. All you need to do is you draw your graph. So this is arc 10 graph, and this is our 5 pi on 8. So the area we want is the area which is bound by the straight line, the y-axis, and the graph here. Again, there are 2 ways. You can simply find the point of intersection first by doing intersection. And what I did, I again stored this value. I linked it. I just called it k. And then you can go menu, analyze graph, and we want bounded area. And if you do that, you just show this graph from there to there, and the bounded area is shown. Or once this value is given there, you can use those 2 functions, f2 in x minus f1 in x. Of course, the question was asking write down the expression for the area. That's just to help the students, so that has to be done because this is part of the question, so the marks will be there. So this is part of high-level thing. So next one I will look at is a few studies questions. So on every paper you will have the questions on modeling with functions, and they call them sort of unfamiliar function, even though here we just have in reciprocal of a quadratic and quadratic, but for study students, of course, those concepts are much more difficult. So the question would say, sketch the graph indicating clearly the points where each graph intersects the y-axis, solve this equation. So again, we enter one function and another, and as Pam was already talking about trace, if I use the down arrow here, it gives me the intercept of my quadratic, and if I go up, it gives me the intercept of the blue graph. My students recently asked me in year 11, we started, how do I go between one and the other? So we have just used the arrows. So of course, you need to set it up in the window as indicated on the exam. So the trace function is very useful here. And then we need to find the points of intersection. Again, for study students, important to write if we are just solving the equation as the question asked here, we are not finding points of intersection. We're solving the equation, so the answers need to give x values. So that was the first question. Now we go to question 2.1, which is a bit more complicated because we have this vertical asymptote. And then again, we want to sketch the graph and find the minimum, maximum, and determine the range of the function. So sort of typical studies questions. So if I sketch this graph for study students, the vertical asymptote concept is a bit difficult as well, but trace is very helpful here, because if I go to trace, that clearly shows me the vertical asymptote straight away. It says when x is 0, it's undefined. The other way of doing that with other functions, if it's x minus 1, you can type 1 and it will come up with the vertical asymptote. So that's something helpful. Still, they need to write x equals 0, not just 0, as we commonly see in answers as well. And then the other part is just to find the turning points, and from here look at the range between minus 10 and 10. So clear it's minus infinity to here plus minus to 10 to infinity. This is the exponential function where we have two unknowns. Here we have k and c. They say c is greater than 0, and we are given two pieces of information, the y-intercept, and it says find the value of k and then another point. So we can't really define and try to solve, given that it doesn't work very well, unfortunately, with the TI-Nspire non-CAS. So what we do need to know, they need to know that the value of when it's 0, we have c to 0, which is 1, and then use numerical solve by entering this equation, and again store the value as a k. And then we can define this function because the k value now is known, and then we can go back and substitute the other point with numerical solve again to solve for c. I never ever ask my study students to solve by hand those questions with quadratics, way too hard for them, so numerical solve is the way to go for study students. Now, the other question would be, what is the horizontal asymptote? So again, there are ways of doing trace and see where it approaches. Of course, we know it is the number by itself, but not all of them know that. So if we do Control T, the table appears, and then if they scroll down, they can just look up the numbers, and clearly if we go lower and lower, we see that this number here is about 16. So if I press Control T again, I don't have this number. I could then, they could check by entering 16, and of course extending the window something to, if they still unsure that this value, if I go to 50, so clearly it is the horizontal asymptote. Again, they need to write the equation y equals 16 to get full marks. They would get 1 mark for 16, 1 for y equals 16. The other very useful numerical solve is for any sine and cosine rule, and again, as we know with study students, it is not the easiest for them to rearrange equations. So a typical question, two sides and an angle, and if we use numerical solve, just entering the equation, it does solve it. Notice that I have this document in the Greece, as the students should be. Now, if it is a standard level question and they ask for the ambiguous case, we can put, given that b is greater than 90, and that gives us the other angle. So that could be for standard level and high level finding ambiguous case if it applies. Similarly, if we have the question requiring the cosine rule, the easy way to do is we just enter 10.6 store as A, store as B, store as C, so the calculator remembers those values, and then you just numerical solve. We're solving for the angle, enter the equation, so that's as simple as that. Don't have to use theta, which is of course in the template. They can put X there, and we are getting the answer easily. So sine cosine rule with numerical solve will work very nicely as well. I use that in the calculator screen. Now, other typical question for studies is the chi-squared question. So this time we have a psychology student carries an experiment to determine whether or not the caffeine in coffee increases reaction time. So we have a table here, normal coffee, decaffeinated, and reaction time faster, same slower. So carry out a chi-squared test to determine whether or not caffeine affects reaction time, state your hypothesis, and use the 5% level of significance. So they should be well trained to know the null hypothesis has no effect, they're independent, and the H1 is caffeine does have an effect. So what we need to do, we need to use the template with the matrix, and the matrix is 3 by 2, and then we again save this matrix as observed matrix, and then if we go to calculations and statistics, stat test, and then we have our test here, which I have already chosen just to save some time, and if I press enter here, I can see my probability. They will not be required to actually know the critical chi-squared value. It will be given, but recently most of the questions were actually about the p-value. So here it is pretty close to 5%, but it's a bit higher. So we would say that we accept the null hypothesis, and we say caffeine has no effect on reaction time. So that's the typical chi-squared question. The other question which causes a lot of problems is the data given in frequency tables. They still struggle a bit how to deal with the situation. So I have entered the data here, and I will do it in the spreadsheet because it can be done in a spreadsheet all. So we go to stat calculations, one variable statistics, again as Pam said, number of lists is 1. So my variable is was T, I guess, and the frequency was N, and I say OK, and then I get the mean value here, and then I also get the 5-number summary with minimum Q1, medium Q3, and so on. So this thing with frequencies, they do need to remember that they have to use the frequencies. This question again is a typical linear regression question. So we are given here the situation that he measures the circumference of trees that were growing at different distances from a river bank. So these are the data. So there are some questions here, draw it, and then write the mean distance, X mean and Y mean, because the students need to know that this point M needs to lie on the regression line. Find the R value regression line, draw the regression line, and use the regression line to estimate the distance. So again, the data is entered here, and we just draw a graph with X and Y and enter our regression line. Now what's important when you do the regression line in the calculator screen, the difference is that the regression equation is saved, and the student can see when it's saved. It will tell them whatever function they have. If they start on a new problem, it says it's saved in F1 or whatever, and then this equation can be used. Of course, they can use mean for X and mean for Y, but just typing, and if they go back, so we see 26, and this other value will lie on the regression line, and this point needs to be marked clearly with the coordinates, not just some dot as some do, but clearly marked to score the lines and then estimate the value in 40 as in the question, since, as I said, this value is appearing here, so that's easy to get this value without trying to retype or equation or write it down somewhere and so on and so on. So that's a big advantage of using the calculator screen. The last question here is calculus question. So the function is defined, sketch the graph, find the gradient at a given point, the equation of the tangent, and where the tangent cuts the graph again. So Pam did some of these. So here I just have a graph with the turning points. And again, similarly as Pam did, if we go menu, analyze graph, and we get our dy dx and put the point, it gives us a gradient at this point. And the advantage is that then we can draw a tangent. Now, on the computer, you can extend the tangent to see where it will cut the function again, but in the press to test mode, actually this functionality is disabled. You can't extend the line. So of course you could retype it, but it's not very accurate if we use only 2 decimal figures. Of course that can be changed in the settings. So we might change the float to a higher one, which I would have to probably do again because it doesn't change it because it's already displayed. But what can be done in this question, I of course know that I want ddx when x equals point that, so this is my gradient and I can store it as a gradient, and then I can use numerical solve to solve a linear equation to find the constant. So y equals mx plus c, so y is the value of the function in 1.5m, we already know, times 1.5 plus c. And the calculator will quickly solve that, and then I store it as C. What I can do then, I can actually now sketch mx plus c. Calculator knows what m is, what c is, and now it will beautifully cut my graph, and I can find the points of intersection. So that's a way of overcoming the difficulty with trying to save to retype the equation or don't have it very accurate. I think we are a bit out of time, so I will stop at this point. There are files on normal distribution, but I think we covered quite a lot here. So I stop sharing, and thank you for listening, and back to Brian.
Okay, thank you very much. Some very appropriate examples there and beautifully illustrated, so thank you. I had a few people say when I mentioned before that this is our penultimate webinar for year 2016. That means some people said yes, this means there's one more to come, and there it is. So in 3 weeks' time, Problems Worth Exploring, episode 2. So stay tuned for that one. But thank you very much to this evening's presenters, both Bojina and Pam. And can I just point out to participants that Bojina and Pam, if you want to see any of their earlier webinars, they're all available on the website, not upcoming, but on demand. So this is looking at the entire archive here, and Bojina and Pam have a set of webinars on statistics, probability, complex numbers, functions, and algebra. So back into the earlier archive there, well worth a look, and you can find that simply by going to the education.ti.com website, Australia, New Zealand, and click on the webinar link there. So just to tidy us up with the housekeeping here, a reminder that following this you will get, as you have attended this webinar, a professional development certificate. These things are becoming very, very valuable, and you will also, within a couple of days, receive a follow-up email that contains wonderful things like the TNS files that you just saw expertly presented and the accompanying Word documents. You would have seen one pop up on my screen a short while ago as I was reading it. So very, very useful documents there. Please, we value your feedback, so as you log out, could you please complete the 60-second feedback sheet that will pop up on your screen, and bear in mind that you can always visit us at that website that I indicated a moment ago, where you see a whole range of more resources. Some of my favourites in the Australian Curriculum Inspired and particularly the Senior Curriculum Inspired activities, where teachers have written in to share lots and lots of activities that they have written, and there's lesson plans ready to go in your classroom. A new addition to this is coding, for coding on both platforms, TI-Nspire and also the TI-84 plus CE, if that's the machine that you're using, and a lot of these webinars and snippets thereof are now finding their way through to YouTube, and that is our YouTube channel. If you're in Victoria, specifically Melbourne, can I put in a plug for the Learn and Energise Connect? This is a face-to-face professional development event that will be at Mount Waverley Secondary College on Tuesday the 19th of December. So thank you once again to both of our presenters. Wonderful material, and all the best for students heading towards their IB exams. Thank you, Bajena. Thank you, Pam.
Thank you.
And
Thank you.
Good evening to all.